Hello everyone. Today we're going to see the basic probability rules, the rule of and the OR rule. These two rules are very important and in my opinion very easy to understand how they work. So last time we have seen what is the sample space, how we can display, and we have seen the importance of the tree diagram especially, which is the most common, as well as the list. So let's start first with the end rule. We will see an example just now. So we flip a coin and we spin a spinner labeled ABC. Let's have a look to these two. Let's think about when I have a coin and the spinner. If I would do the experiment independently, the probability to get heads and tails is a half and a half. And obviously here, because these areas, as you see, are equal, nothing is bigger. They all take a third of the total. It's a third for each. So, why these events now are called independent? Because performing the one does not affect the other one. Now, if I perform the experiment, all of these are the possible outcomes. I can get heads and A, heads and B, heads and C, tails A, tails B, tails C. Now, a tree diagram displaying that would look like this. I fill in the probabilities, heads and tails, and then we spin the spinner, A, B, C. And as we said, a third everywhere. Now, let's think about this. What would be the probability to get head and A? Head and A, obviously, it is one option of the 6. So this must be 1 over 6. And on the tree diagram, it is this path here. Now, let's see now the probability to get head. What would it be if I would do that only? The probability to get a head is a half, and the probability to get A is 1 over 3. Now, let's take a moment and see these two values here, a half and a third, how can they make 1 over 6? Because there must be a connection. Okay. This and that, if I multiply them, I get 1 over 6. So what we have just seen, that the probability of an event A and B to happen is the probability of their product. Probability of A times probability of B. Eventually, we can see that on that path we multiply a half times a third, because this is what I wanted. This is the event I wanted to take the probability of. Let's move now to the next one, which would be the OR rule. So, again, we keep the same experiment. Heads, tails. Alright. Let's now think of the probability of that. I want to get heads and A or tails and C. From the list above, I can see that I want these 2 out of 6. So it is 2 out of 6. Now it's time to see them separately. What is the probability to get heads and A? Only that, which means 1 out of 6. As well for that, if I see that independently, it is 1 over 6. So the probability is 1 over 6 and 1 over 6. But how these two now can combine to get the 2 over 6? 1 over 6 plus 1 over 6 would give me 2 over 6, which is simplified to a third what we got initially from here. Now, as a summary, what we have seen, the probability of an event A or B to happen is the probability of A plus probability of B. Now, let's make a small summary here on how are calculated the probabilities on a tree diagram. Step number 1, you read it correctly, you make a tree diagram. Step number 2, you write correctly the probabilities. You study the problem to see what is going to be here. Because not every time is a third, a third, a third. Yes? Or a half. That spinner was fair. That dice was not biased, so it was not much of a study. Okay. Last step. I see which probability I have to calculate. Therefore, I highlight the paths that are the ones I want, like here, to get head A or tails C, these two paths. And then, as a final thing, when I have a path, I multiply the numbers I find, plus I add the other path. So it is this times this, plus this times this. Okay. As a summary, when two events are independent, A and B, so and means times, or means plus. Let's go for another example now. We choose 2 marbles from a basket containing 4 blue and 3 green. Now, let's keep this on top. In this time now, the events are called dependent. Why is this? What does it mean, dependent events? Before they were independent, the dice and the coin, the coin and the spinner were not affecting each other. But what about now? Alright, so first of all, I will be at the end holding 2 marbles. And I will have maybe 2 blue, 1 blue and green, 1 green, 1 blue, or both green. Yeah, any other scenario? No. So, how will I now display that? First, I put my hand in this basket, for the first time. So, I can get either a blue or a green. Simply, since I have 7 in total, I fill in the first branch. Second, I put my hand again. What is the difference now from before? Now, I have to choose only from 6. One is taken before, one is picked here. And therefore, that's why these events are called independent, because not only it's changing from 7 to 6, the sample space now is smaller for the second pick in both, in any of these, 4 actually, in any of these. But also, if I pick a blue here, then I have 1 blue less to pick as well. Here, if I pick a green, then I have 1 green less. So also, you see, these are not the same with this. All right. In that moment, I would like to, as you saw here, I made a small change. So what does this mean? In these dependent events, so probability of A and B, this means this times this, but this means, we will see that later, probability of B given that A happened. What it means, I have to consider what happened here in order to find the correct probabilities. So here the event B, the second pick, I study to see what are the new probabilities, because it depends on what happened before. So these 2 events, first pick, second pick, are dependent. Now, let's follow the same like before. Both blue. Both blue is this path. Yes, what we do the probabilities? On a path, we multiply them. Both green. Both green is this path. What do we do? This times this. Okay, now, let's put another question. What would be the probability to have at the end the same color? So I have 2 marbles of the same color. Okay, what does it mean? Do we already have this? Yes. I want to have blue and blue, or green and green. So blue and blue, this times this, which we have already. Or, meaning plus this times this. So this simply is this plus this. for 9 over 21. I haven't simplified the fractions, but you can do that. We always simplify at the end. Now, think about this question and we see next time for that. Okay, now let's have a look on another example. Take some time, press pause please, so you can study this problem. Alright. What it says. I have bag A that contains 3 red and 2 yellow, bag B 1 red and 4 yellow tickets. Now, here is where we have to start to read correctly. A bag is randomly selected by tossing a coin, meaning if I bring head, I pick bag A, or tail, bag B. It doesn't matter what is head or tail and which bag I pick because it's a half and a half in any case. And then after you have chosen bag A or bag B, one ticket is removed from it. Determine the probability that is yellow. So, here it is very important again to read correctly and do the correct tree diagram. Meaning, here are the two bags. So, what happens? In the first event, we toss the coin, a half and a half. If it is heads, let's say we go here. If it's tails, we go here. And then we put our hand, according to which bag we have chosen, in some of these. Okay, so we have these probabilities. Now, what we want? The probability that at the end we will have a yellow ticket. Now, let's see. In which of these paths we end up with a yellow ticket? So we can either put our hand in bag A and get a yellow, or put our hand in bag B and get a yellow. So simply this times this plus this times this. Alright. Now, I would like that you try this at home, and we will go through together in the next time. And also I have the solutions. And have a go, please. Don't leave that, and we see next time. See you.